Welcome to EMScan Lab. Today what we'll be doing is looking at the capability of the ERX Plus and the high resolution measurement that it can do. So what we have set up here is the inside of a Wi-Fi access point. So we've just pulled the board out. This is an off-the-shelf component, and we have it on the ERX Plus connected to the EM Expert software. So everything is set up and ready to run. You can see that we've already in fact imported the overlay for this file. And what we did is just take a picture and import this into the software. So we showed in another video in the EMScan channel how to do this. We also have focused in on a particular area of this board. So if we zoom in here on this one chip, we'll be focusing on this for today's test. Now we also analyze this entire board in another video on EMScan channel as well. What we'll do is look over a small frequency range. So we've set up here in our settings from 260 megahertz up to 400 megahertz. We set a resolution bandwidth, and we're starting at level 1 resolution level. So we'll do that test very fast, and you'll see that it only takes a couple of seconds to run. That picks up a few of these emissions. It also gives us a big blob of red over the center of this IC. What we want to do now is start to explore in more detail what's happening inside this chip. So we'll actually zoom right inside this chip here, focus in. Now this is just a couple of centimeters in size. We'll go to the settings again, and we'll increase the resolution level to level 2. So we can see now that the resolution is set to 3.75 millimeters. And what will happen is the entire scan array will actually move those 3.75 millimeters. We're also going to turn on interleave scan. And what this will do is measure twice to basically fill in what we call blind spots. Because the polarizations of the probes can only pick up one field, if we measure twice with 2 sets of probes, we can basically cover that entire polarization and get a more complete picture of the emissions. So with those settings changed, we'll run that. And now it'll be a couple seconds per scan, and we can see very quickly progressing through the array. The entire system is moving. We sample in 4 different locations because we've split that 7.5 millimeter scan area up into 4 cells of 3.75 millimeters. And then because of the interleave, what we'll do is we'll capture that again. So really we do 8 scans, combine those all together, and now we can see the resulting scan here. So this is showing that same area now with the subgrids. So we can see that the grid area is now half of the size as it was previously. If we turn off the subgrid, we go back to the 7.5 millimeter scan. So here we can also see the advantage of this. Because we've measured in more areas under the probe, we've actually picked up a couple of new signals. Now this was at level 2. This process can proceed all the way up to level 7, and in fact level 8 in the software. And if we see here, we see level 8 is equal to a step size of 0.06 millimeters. Now obviously this would take a long time, so we wouldn't go through that whole process right now. But we have run some scans at higher resolutions. So if we look at this one here, you can see some timings. So this scan was what we call level 3. So it was over that same 140 megahertz range, 1.8 millimeter spatial resolution, and you can start to see some really good detail inside the chip. So this scan took about 45 seconds. Now we took it even further, and we focused in on one of these spurs and did level 6 scan. So already here we're looking at 1/4 millimeter spatial resolution. And you can see inside the chip now you get great detail about where those signals are coming from. Now we have zoomed in on one particular spur here just to make that happen a little faster. But once you've identified the particular location, the key frequencies, you can set up this scan to run with as high a resolution as you want, and the trade-off is just a little bit extra time. So that's our quick explanation of how to run high-resolution scans on ERX Plus. If you have any questions or comments, you can post those below. And of course, join us again at EMScan Lab for more videos. Thank you.